All right, today we're diving into something called the Magnus Effect. It's this incredible kind of hidden force in physics that explains how a little bit of spin can make things fly in ways that, well, seem pretty much impossible.
Okay, first things first. Just look at this basketball. It's not falling, is it? No, it's literally flying. It's soaring through the air instead of just plummeting straight down. So the big question is, how is that even possible?
So let's set the scene. We're at the Gordon Dam in Tasmania, and we're talking about a drop of over 126 meters. That's huge. Now, if you just drop a basketball from that height, it does exactly what you'd expect. Falls more or less straight down. But, and this is the amazing part, if you give it some backspin just as you let it go, something absolutely incredible happens. The ball just takes off. It catches the air and sails away, traveling a ridiculous distance sideways.
Now, as much as this looks like some kind of magic trick, I promise you it's not. This is a powerful, real-world example of a really fascinating principle in physics.
Okay, so let's get into the nitty-gritty and break down the actual science behind this flight. We're going to look at exactly how a spinning object can manipulate the air around it to create this kind of lift.
And the name for this whole phenomenon is the Magnus Effect. It's the key idea that explains what happens to any rotating object, whether it's a ball or a cylinder, when it's moving through the air. So how does it actually work? Well, as the ball spins, one side is moving with the airflow, right? It kind of drags a thin layer of air along with it for the ride. But on the other side, the surface is spinning against the airflow. This causes the air to separate from the ball much earlier. You get this imbalance. The ball is now pushing a whole lot more air down than up. And as good old Newton taught us, for every action, there's an equal and opposite reaction. So that imbalance in airflow creates a difference in pressure. And that results in a force that literally pushes the ball upwards and forwards. That's the lift we're seeing. It's what makes our basketball fly instead of just fall. And believe it or not, this isn't some newfangled discovery. The Magnus Effect has a surprisingly long and fascinating history, and some of the greatest scientific minds were noticing it centuries ago. In fact, way back in 1672, Isaac Newton himself was watching tennis matches at Cambridge and jotted down notes about the ball's weird curved flight. But it took almost 200 years until 1852 for a German physicist named Heinrich Gustav Magnus to really study it, describe it, and, well, get his name attached to it forever. You know, you could argue Newton was first to the punch, but let's be real. He's got plenty of things named after him already, so Magnus gets the credit for this one. So that brings up a really interesting question. If this force is so powerful, where else do we see it happening? And the answer is, well, it's pretty much everywhere once you know what to look for. Let's kick things off with the world of sports, because athletes, whether they actually know the physics behind it or not, have become absolute masters at using the Magnus Effect to get a leg up on the competition.
Seriously, think about it. In tennis, a player uses topspin to make the ball dive down hard over the net. In soccer, a perfectly struck free kick can bend around an entire wall of defenders. And in golf, you know that dreaded hook or slice that sends your ball into the woods? Yep, that's the Magnus Effect, just not working in your favor. All of these are perfect real-world examples of spin controlling flight. But it's not just about sports. It gets way bigger than that. The Magnus Effect has been used for some truly mind-blowing engineering projects on a massive scale.
See, the whole approach is completely different. A traditional sail just catches the wind. It gets pushed. But Flettner rotors, which are these huge spinning cylinders on a ship's deck, they actually use the wind by spinning. They deflect the air to create forward thrust, just like our flying basketball. And this is not just a concept, it's real. There are modern cargo ships, like the E-Ship 1, that use 4 of these giant rotors to help them save a ton of fuel. People have even experimented with airplanes that used spinning cylinders instead of regular wings. Now, get this. Those experimental planes actually generated more lift than planes with normal wings. So what was the problem? Well, they also created way too much drag. So in the end, they just weren't efficient enough to be practical for everyday flights. So here's the big takeaway. The very same physical force that lets a soccer player bend a ball around a defender is also being used to help push a gigantic cargo ship across the ocean. From the sports field to the high seas, it's all the same physics. It's all the Magnus Effect. It really makes you wonder, doesn't it? What other amazing, invisible forces like this are out there, hiding in plain sight, just shaping the world all around us in ways we've never even imagined?